All right. Good morning, everybody. We have people still trickling in. I guess there was an issue with the Zoom link. So hopefully, I just sent an updated email. We'll get some more people joining us, but I'm very excited. This morning, we are being joined by Emily Fisher and Jeffrey, I might say her name wrong, Geddes, to talk about FarmFlux. And so, I will pass it over to Emily and let her give you a little background and present.
Hey there, everyone. Thanks for the opportunity to share some information with you. I'm coming to you today from NASA headquarters, actually in DC, but I'm a professor at Colorado State University, and so I live in Fort Collins, if you caught some of the earlier chat. So I am hoping to share with you some information on an upcoming science experiment that's relevant to agriculture in Colorado. I'm the deputy PI of this mission. With NASA, we call things missions. It's still funny to me, but that's what they call these experiments. And Jeff Geddes is across the room from me. The lead PI is Glenn Wolf, who's at NASA Goddard. He has COVID today. And then also in the room with me, but you can't see him, is Roy Johnson, who is helping us with the logistics for this. So, um, so I'm going to give you just a little bit of information on why NASA and why something focused on farms. So FarmFlux is part of the NASA Earth Science Pathfinder program, and NASA Earth Science develops different observing systems for different aspects of our Earth. So weather and atmospheric dynamics, climate variability and change, water and the energy cycle, carbon cycle, and ecosystems, the Earth's surface and interior, and also atmospheric composition. And so the 2022 NASA strategic plan was informed by a National Academy's decadal survey that was developed in 2017, 2018, that highlighted the need for additional observations in this area. So as I'm going to share with you, this FarmFlux is a aircraft, what we call an aircraft campaign. So we'll be using aircraft to do additional observations. But NASA supports a variety of different capabilities that range from ships and balloons up to aircraft and then to satellite observations. And so the satellites are sort of permanent, more permanent, nothing's really permanent, right? But a permanent observational capacity. And then they also support deployable observations. So these are things that are sort of suborbital, so not orbiting the Earth. And those include airborne facilities like what I'll share with you. So that's what we'll use for these. So the current Earth ventral or suborbital cohort, so these are NASA missions, the sort of current NASA missions that use the suborbital assets are focusing on several underobserved North American environments. And so FarmFlux is just one of them. So other ones that you may hear about are Inspire, which is focused on cumulonimbus clouds, or those very large smoke plumes that from the Cameron Peak fire and some of the local fires, you saw those really large plumes. They inject really high up into the stratosphere, and they have implications for both air quality, as we experienced in Colorado, and climate. There's a mission focused on air quality. This HAMMOck one will go to Mexico City and Atlanta. And then there's two other missions that are focused on important aspects of the Arctic, one measuring melting glaciers across the Arctic, and the other one focusing on water flows and chemistry along vulnerable Arctic coastlines. And so FarmFlux is one of a cohort of NASA efforts that are being launched this year and next year that fill the space, let's say, between what's observable by satellite and the ground using aircraft observations. So FarmFlux will connect the satellite observations of trace gases, in this case, to drivers on the ground. And I'll spend a little time on this map here again. But this is an example of what is observed from space. So the colors here represent the ammonia abundance from satellite. And so when a satellite looks down, it is measuring a column. So how much of a certain trace gas is from the ground all the way up through the atmosphere. And in this case, you can see ammonia, and the colors are larger amounts. And so this is a map of the US. The dots here we don't need to worry about too much, but those are ground observation sites that measure ammonia or a related species, ammonium. And what you can notice from the map is two things. One, there's a lot of red in certain locations, and I'll tell you what the circles are here in a second. And also, there aren't as many ground observations, particularly in the middle here, as there are compared to the East Coast. So, this actually measurement of ammonia comes from a NOAA satellite, but the NASA mission will support flying aircraft in these circles. So there'll be two aircraft, one that will fly and measure the interaction of the atmosphere with crops, and one that will measure the interaction of the atmosphere with animal agriculture. Those are the two different circles. The big ones is a larger aircraft, and the blue ones is a small aircraft. And the idea is, okay, this is what we see from space, and we could look at a bunch of different trace gases. This is just one example. How does that connect to what's happening on the ground? So here is a map of different crop types that I'll circle back to. That's what the colors represent. And here over on the right is animal density units. And so the idea is that the aircraft helps go from this satellite view down to drivers on the ground and helps that observing strategy. So FarmFlux is specifically designed to observe the cycling of trace gases and particles between agriculture and the atmosphere in those areas. While this is a national scale effort, we can only observe in so many places with an aircraft in those circles. And so livestock emissions contain both greenhouse gases and reactive gases. Same for crops. And for crops, as I'll talk about in a second, it really is an exchange. It goes in two different directions. So the reactive gases, the greenhouse gases are important for climate change, and the reactive gases are important for air quality applications. Both the impact of air pollutants on crops and livestock, and also the impact of those emissions on particulate matter and other air pollutants. And so, some of these air pollutants can be observed from space, and some of them can't. Oops. Sorry, did everybody get left in? Let in. There's a bunch of dings, but I assume everybody can hear that. Okay.
Yeah, I got you.
All right. So I just said, wait, I said I would let people in, and I'm not doing that. All right. So, all right. So you should think about this. Air quality and agriculture interactions are a two-way street, especially in Colorado, as I'll show you. So agricultural activities are a source of a variety of different greenhouse gases, but mainly mainly methane and N2O. Also a source of ammonia. And urban areas are large sources of a different set of pollutants: nitrogen oxides, sulfur dioxide, a variety of different volatile organic compounds. And together, some of these emissions combine to form particulate matter and form ozone. And when they transform in the atmosphere to form these two pollutants, these are harmful to people, crops, and livestock. And so we need to understand this exchange so that we make sure we have clean air everywhere. And so here's an example of some work that I've been a part of, which has been really quite fun, working with agricultural economists, showing specific examples that are very relevant to Colorado. So for example, when we have not a huge increase in the pollutant ozone, that has observable impacts on worker productivity. And also not a large increase in PM 2.5 is also increased with productivity. So very relevant to Colorado. And then this is a study that we actually worked on a dairy in Colorado, showing that the fine particulate matter, when it is elevated, and often with smoke in our area, is negatively associated with milk production in dairy cows. So FarmFlux will be observing nationally over high density agricultural areas, but there's 3 intensive observing periods that are going to overlap Colorado, and there's a few reasons why we're doing this, but it's partially why I'm talking to you today. So again, the cropland focus will have a aircraft base in Colorado, and this circle here is an approximate observing circle for P3, the NASA P3. So it's a larger aircraft, so it's got a larger radius with which it can fly before running out of fuel. So it can operate in this space for about 6 hours. And then the small blue are major concentrated, high density concentrated areas for livestock operations. And so one of those is Colorado. So there'll be, as I'll talk about in a second, 2 returns to Colorado, and the large aircraft will maybe go over eastern Colorado a little bit. I hope so, but it may end up focusing a little bit further east. And so why is Colorado particularly interesting to observe? Why are we coming 3 times? So the first reason is that air pollution here is really complex, and right, a satellite only sees a column, the full atmosphere. So it's very hard to connect it to the ground. So it's a great place where there's complexity and there's a lot of different air pollution sources. So for example, right, our northern Front Range area, it exceeds the standard for ground level ozone, a respiratory irritant. Many of you who come in and out of Denver, every time I come in back down from the mountains, right, you see the brown cloud associated with the Front Range, and particularly Denver. Our area is routinely impacted by wildfire smoke. We also have a lot of oil and gas activity, even though that, the emissions we do think have been going down from oil and gas activity. There's a lot of overlap between oil and gas and agriculture in our area, and so a variety of different sources of trace gases. And so that's one reason why Colorado is a very interesting place to study atmospheric chemistry, because there's a lot of different sources to untangle, and important to connect those with ground and aircraft observations. The other thing that's great about Colorado is there's a lot of complementary observations that exist here for other seasons. So when this mission was pulled together, we had proposed it as a large $30 million scale experiment, and it was cut to 15. And so we're trying to make sure that we fill in gaps. And so we're going to places where there's existing information already that can be leveraged. All right, so these are the planes. So FarmFlux will use 2 different aircraft as the deputy PI. I'm running the operations for the small plane, which will be a Dynamic Aviation A200. So that's a picture of it over here. And what we do when we do these observations is we basically turn this into a flying laboratory, and we stuff it as full as possible with as many instruments as we can. So we make a priority list. They're open competed for people to join the team, and then we just work down the list. These are the measurements that will be stuffed into this plane. There'll be inlets at the bottom of the plane, so the gases will get sucked in real time into the aircraft and then measured in what we call instantaneous or in situ measurements for many nitrogen containing compounds. So ammonia, NO2, nitric acid, and N2O, because the focus is on the exchange of nitrogen. And then these other species are both important as greenhouse gases, but also help us attribute what we observe. And then we also measure, because some of these, particularly ammonia and N2O, once they're processed in the atmosphere, they form particulate matter. And so we're also measuring the corresponding species in aerosol form. And then the large aircraft, so what will be flying in the black circles will be the NASA P3. So this is a much larger facility. And so it's a much larger flying laboratory, and it'll have a wider range. These are what's confirmed, but we're working right now to add on other university assets to expand the measurements. So when you do atmospheric chemistry, the more you can measure, the better, because then you have clues as to where things are coming from. You use different tracers of different activities. So we're working on trying to find some funding for folks at CU Boulder and another team at CSU to continue to add to the measurements that are on the P3. So for the crop side of things, the research questions connect nitrogen use efficiency and crop health. And so we'll be looking at, as you can see where the circles are, one deployment or one observing period will focus on corn and soybeans, sort of focusing in this area. And then another one will focus on more specialty crops in California. And so we're looking at how factors such as fertilizer input, soil moisture, crop stage, and crop health change emissions and deposition for trace gases and the underlying surface. For those are complicated questions. And when I show you the schedule, you'll realize we only have a short window to do these observations. And so in order to connect those pieces, we are designing observational strategies that cover different crop and condition combinations. And so, for example, here's some experiments that observational experiments that will be conducted with the large plane. For example, we'll go to North Dakota is interesting because there's a late thaw and very low livestock density in that area compared to some of the other areas. As you go down to Nebraska and Kansas, there's really quite large east-west gradients in rain-fed versus irrigation activities over croplands. Illinois and Indiana have very large differences in fertilizer choices. I'm not super familiar with that, but we have some information on that. Places like Arkansas have high moisture soil. And so we're looking to cover a wide variety of different crop and environmental conditions with the large plane to connect to identify patterns between the exchange with the atmosphere and other activities and conditions on the ground. So why is NASA doing this now? What's neat about it is we've only just been able to do this type of work. So atmospheric chemistry instrumentation for nitrogen containing compounds just finally got fast enough. So we finally got instruments that can fit onto planes and can do measurements with enough fidelity at sufficient speeds that you can do the calculations needed to understand the flux or the exchange between the surface and the atmosphere. And so there's too much on the slide, but this is how this works. So you have, imagine you're flying through the air, and the air, it's a warm sunny day, so there's nice little thermals and there's a lot of turbulence, like shown in this coffee mug here. And as you fly along, you see variations between a trace gas and the vertical wind speed. So when the winds are pushing the air up, you see an increase in that trace gas, and for example here, and when the winds are pushing down, when they're sort of, as you have these little turbulent eddies, you see things go down. Well, you can use that with some relatively sophisticated math to calculate the exchange. So how much methane is coming up from, in this case, up from the surface, or methane doesn't deposit it, but for a depositing species, you would see, oh, that's actually being lost down to the ground. And you can see that in these eddies as they fluctuate. And so we fly through these eddies, and you're able to calculate the exchange of gases between the ground and the atmosphere. And then you can use some tools that include some machine learning tools and some other modeling to connect that observation down to a place on the ground. Or it's not perfect. You can't see you can't see very small structures, but you can get down to reasonable footprint scales. So we're finally at that space in scientific time, I think, where we're able to do this. So for animals, and this is the piece that I'm leading, the scientific challenge is to go from really nice work that's being done at the individual animal scale. And so maybe some of you are familiar with the CSU facility out at RDEC, our Ag Research Station. So there they're doing they're using these green feeds, for example, that you see in this picture, where they're measuring the breath of the cow essentially. And so, in order to connect that all the way up to a satellite, a lot of different observational strategies are needed. And so, FarmFlux is providing the aircraft, but we're linking with teams. We're working on linking with teams that have mobile measurements on vans. And my team did some work on this last spring in our area to work out some of the logistics, and then towers. And so, an individual animal is great, but it's really hard to measure every individual animal. There's a lot of them. And so mobile labs can measure sort of nearby deposition from livestock. Towers provide regional estimates. And planes provide sort of instantaneous facility scale emissions and evolution by being able to move around. So this yellow here is like, imagine the wind is blowing from left to right here. It's pushing a plume this way. We are able to go into that plume and we'll try to line it up at the same time that a satellite is passing over. And so what we do is take all these different observations and we put them in what's called a chemical transport model, and we see if we can reproduce what's observed by all these different platforms to make sure we have a full understanding of the system and we can predict how it might change going forward. So when the small plane comes to Colorado, it will look different than the large aircraft. The large aircraft will fly sort of low and slow in straight lines over crops. And the small aircraft will follow plumes as they disperse and interact with the ground from, in our area, dairies and cattle feedlots. And so this is something that we developed the methods with National Science Foundation support back in 2021 and 2022, right after the pandemic. It was supposed to happen during the pandemic. The observing strategy was designed with Bill Hamrick, who at the time was leading the Colorado Livestock Association, to be non-invasive and ensure safe distances for all the animals. So the reason why you need a small plane for this and you can't use the large plane is because it requires flying low to the ground, and it requires sort of nimble sampling to make this work. So what we do is the plane this time when it comes to Colorado will very likely base in Greeley. So the plane leaves Greeley and will fly across the state, but will come and circle a facility staying half a mile away. So people may not actually at the facility even notice the plane, but stays half mile away and circles at 1,000 feet, then comes down to 500 feet, identifies the direction of outflow depending on the wind conditions that day, and then moves downwind and sets up a series of think of them as like racetracks. Actually, that's the most efficient way. They're not really a square, not really a circle, kind of like a track. And then we fly that at multiple altitudes, up from as low as we can safely go, which sometimes is 300 feet above ground, but you have to be careful of towers, and you have to be careful of crop dusters, and you have to be careful of just random people in Colorado doing random stuff in the air, because there's a lot of it. And then you go up, and what you end up with on this orange line is a wall of observations. So you have many times that you've flown through the plume, you end up with a wall. And some of the gases that we are measuring deposit to the ground, and some of them don't. Some of them have like 100-year lifetimes in the atmosphere. That's the case for nitrous oxide or laughing gas. Methane has a 10-year lifetime. It's not interacting with the ground, but the ammonia lifetime at the ground is minutes. So, and in the higher in the atmosphere is hours to a day. So we follow the plume. We'll set up another set of racetracks downwind to understand how that certain species are being lost to the ground or forming fine particulate matter, depending on the conditions. So that's how that'll work. And what we'll end up with is something that looks like this. So here's an example. I think this is out in Yuma. I'm trying to remember. It seems like there's too many oil and gas wells for it to be Yuma, so I got to remember where this. Oh no, there's 34. I changed which one I put, but here's an example of a large cattle facility. The size is sized by the number of the max animal capacity. So that's not how big the facility is, obviously, that circle. So we go around and the wind is going this way, and the darker colors here are enhanced ammonia, and we're able to follow that 25 kilometers downwind and create different walls of measurements. And it ends up looking like this. This is the data that you get. So here's height above ground, and this is sort of our first pass here. So that's like here in this zone. You can see a big plume, and that plume dilutes as we go downwind, and we can, from that, get multiple estimates of the flux of ammonia, in this case in like grams per meter squared, so like passing through an area per time from that facility. And that's how you do those calculations with the small aircraft observations. So we'll take those data from the two planes, and along with the ongoing routine NASA satellite observations. And we have a science team that will work on answering questions, specific questions, but they fall into really these four bins. So one is, what's the magnitude of emissions and near source fate from from large livestock, concentrated livestock observations? Two, how do emissions and depositions of trace gases vary over croplands? And how does that vary by environmental conditions and crop type and all of those sort of differences? What are the properties, both the physical and chemical properties of particulate matter in ag regions? And then what's the relationship between agriculture and air quality? And how do you best leverage long-term satellite observations to understand that, now that we have a much better understanding of what's actually being observed from the satellites? So there are several windows, and part of the reason I'm talking to you now ahead of this happening is to see if anyone is interested in becoming a sort of stakeholder associated with FarmFlux. If you want to join any collaborative efforts, we have time to get that in place. So this is the calendar that we're looking at for these deployments. And so the large aircraft doesn't come till 2027. So I'll start with the small plane. The small plane will do one observing period, 3 weeks at the end of September and into the middle of October this coming fall. And then it will return again in spring 2027. And then the large aircraft is a bit harder to predict when it might pass over Colorado because they'll have a really wide area where they'll fly, and maybe 1 or 2 of days in that window they would pass over eastern Colorado. But those 2 windows will be late March 2027 and then again in mid-May 2027. And so I will stop here in a second. I want to take any questions that you have, and then I want to know if any of you have ideas for scientific collaboration, would like to be formal stakeholders, these kinds of things.
So since nobody's talking, I'll ask a question. You guys
Thanks,
can hear
Owen.
me. You guys can hear me, correct?
Mm-hmm.
Yeah. So I always take this kind of science and call it basic science versus Me being associated with a conservation district, which is more interested in the applied science. Does that starting point make sense to you, or would you?
It it sure does. Yeah, it's
Okay.
I would say on the scale of things that NASA works on, we're a bridge between some of the more discovery science and the applied science. FarmFlux might sit between, but it's definitely not as applied as some of, for example, the work happening at RDEC and some of that other stuff that's happening at CSU. Yeah,
Got it.
you're right. It's on that spectrum, and it's more toward fundamental than applied.
Okay, yeah, and that's
Hmm.
my interpretation of what you said as well. So, whether you want to take your one uh, page that talked about reduction in crops and reduction in was there a reduction in animal weight? I can't remember, but you showed some kind of a set of statistics on certain things reducing.
You were saying here.
Yes,
Yeah.
exactly, exactly.
These are examples of how air pollution has a
Right,
negative impact
right.
in
So,
parts of Colorado. Yeah.
here's my question.
Hmm.
So, I think atmospheric issues have a great impact on how much water is needed,
Yep.
fire issues. Maybe that's more applicable to forestry and rangeland and so forth. I think atmospheric, of course, influences heat significantly. And I guess my question is, I'm not quite understanding where your study wants to go with regards to being able to say to a farmer, such and such impacts land dynamics, and that land dynamic is going to end up resulting in a whatever percent decrease in productivity. Now, maybe I'm just missing your point or your storyline, but it's not evident as to where you want to go towards that goal.
Yeah, it'll be different depending on where we are, but let me give you one concrete example, and hopefully this helps. So, um, and two, I will say that there will be built a bridge between FarmFlux and other NASA initiatives that, for example, NASA Acres and some other NASA programs. But let me give you an example of how this might apply to crops. So um, when we do this type of calculation, we'll do it for something called for ozone, which is damages crops, reduces crop yields, and also damages a variety of other plants. Right in the Rockies, it damages our aspen, for example. But we would do this for ozone, and we would understand then how much ozone is impacting crop productivity in areas where we did that calculation, much better than is currently understood. So you would understand, for example, the ozone damage to plants, and from that you could apply a relationship between ozone and productivity or crop yield. And so we would do a really good job on how much ozone is there and how much of it is being deposited to crops in that area. So that's a very direct link, and I kind of focused on um, the crop side of it. Another piece that you could imagine here is people put a lot of money into fertilizer. You want that nitrogen to be used, not to be escaping accidentally to the air. And so by us flying around under a variety of different conditions, we will understand how much nitrogen is accidentally leaking into the air, which nobody wants, right? And
Correct.
that's the part that's been very hard, right? It's easier to measure some of these things in water. And I know this community cares a lot about water quality. It's been much harder to understand how much nitrogen is being lost and inadvertently moving around in the air. And so that's the other piece that FarmFlux will really will really help with nitrogen loss and redistribution. For example, we could see this spring we're figuring out how to calculate the inadvertent loss of ammonia out of large feedlots and the inadvertent fertilization to all the crops that are sitting nearby, right? And so that those types of calculations, we'll have a really, really good snapshots of what's happening there. Does that help, Owen, a little bit?
I think it does.
It is
And you
very
said,
fundamental, though. You are right. We're on the fundamental side of things, and the scales are big, but that's where we're aiming to get to.
you're right. And thanks for explaining that again. You said most of that the first time, but I guess I just needed it twice to have it sink in here.
Yeah, it's a lot to cover, right? Like, and what's interesting about atmospheric chemists is we stick with our molecules, right? So I've previously worked on wildfires, not in the ag space, because some of the methods that we developed to measure things in wildfire smoke plumes. And now we've sort of rallied the community to work on these types of observations, which we've never had before. But yeah, it's super helpful feedback because I can adjust these slides as we go, right? You're one of my first sort of outreach cases here, other than the farm show, but nobody came to that. That's more.
Okay. And by the way, Emily, I'm in Fort Collins, so
Oh, awesome.
so if you ever want to talk more, or maybe I want to talk more, feel free to reach out to me.
That would be great, actually. We are just beginning to think about some of our fact sheets and things about the campaign. So like having an early set of eyes on, is this the right level of information? Is this the right information would be really great.
Okay.
I can send you his contact information, Emily, if you would like.
Awesome. Thank you.
Sure. And then also this might be like a good, since you were saying this is kind of your initial outreach effort, like the districts have like annual meetings or watershed meetings that you could probably present at, they might like. And when you have those fact sheets too, I can send them out also. I think that would be good. Um, but yeah, very exciting.
Thank you. Yeah, this is just to help people become aware and to offer opportunities for people to join this if you're interested, right? We have a variety of different stakeholder types for FarmFlux that range all the way from yeah, they range of very different scales, just given that this mission crosses the US.
By the way, my only other comment is good luck with your funding given the world today.
We're working hard to keep it going. I'm at NASA headquarters today to hopefully get through one of the hoops here.
Um, Hi, I'm Carissa. I actually grew up on the Front Range, so I worked at Ardec for a couple summers.
Oh, great.
When yeah, it was like the 2019 and through the COVID summers, so it was kind of weird, crazy. But I we just toured Ardec actually at our annual meeting, and we saw the feed um
The green feeds.
breather things, yeah.
Yeah.
And those were so interesting. It was really cool to see. And I'm also it's really cool that it's kind of coming full circle that like we'll eventually be able to learn about that information that you're gathering. So that's really cool. And I also so I work for the CDA, but I also work in the northeastern region of Colorado, and so um I covered like the foothills all the way across to the Eastern Plains, but I live actually just a little bit north of Yuma. And so I was curious, how high do the planes fly usually? Do they
Um,
fly like super high up there?
uh,
Or
well, so it depends on. So, okay, I'm going to answer one thing first so I don't forget, and then I'll tell
that's
you
fine.
that. Okay,
Yeah.
so I'm taking the science team is coming to CSU for their kickoff meeting in a couple weeks, and I'm taking everyone to Arctic for a field trip, all the atmospheric
Woo!
chemists, so we can try to educate the atmospheric chemists on the type of research that happens at a place like Arctic, and
Yeah, that's
different ways
awesome.
of studying this problem from from using different approaches. So I'm trying to open up these sort of interdisciplinary collaborations. So thank you for mentioning that. But
Yeah,
what is interesting about Arctic is it's like too small to sample from a plane. And so even though all
I
this
bet.
work is,
Yeah.
we would pass through the plume from that in 1 second, right? Like it's so tiny,
Hmm.
35
Hmm.
cows or however many they have there at a time, right? Like,
Yeah.
so what would be so optimal here would be to have a large facility collaborate or a group of large facilities collaborate where
Hmm.
we could sort of work to understand really the full system of management and what that sort of manifests in measurements in the atmosphere. So that's one
Yeah.
thing. So I would love to have Arctic be just a little bigger. It would really be allow us to do
Yes.
really amazing science. Okay, second,
Yeah.
Yuma. Okay, so in Yuma, there's a couple of very large cattle facilities and a smaller dairy, not really small,
Hmm.
but like this sits nearby.
Yeah.
And so there, when we sample, what we've done in the past is depending on the wind conditions, we either are getting the emissions and characterizing a single facility or groups of facilities if the plumes kind of overlap. And so we would fly from as low to the ground as possible, which in Yuma is often 300 to 400 feet above ground level. So it's pretty low
Okay.
for even
Yeah.
us. Um, an A200 is not that large, but it's a large enough plane, right? It's a six-seater
Yeah.
plane. So
Yeah.
it's pretty low. And we go up until we don't see the plume anymore in the observations. And usually that, in Yuma in summer, when I've been there, the boundary layer or the mixing height is very high. So that can go up to 15,000 feet. Because it's very dry and you can get really efficient upward mixing. So it depends on the time of day, but what we do is we finish our racetracks, we stop sampling when we don't see much of the plume anymore, right? We try to go all the way to the top, and it's usually pretty close to the top of the boundary layer that we're able to detect the plume. Does that help?
Yeah. No, that's
Yeah.
cool because I was just like, I wonder if I'll be able to see them like fly over my house or something. That'd
Oh,
be
maybe.
cool.
We stay out of the Denver airspace, right?
Yeah.
In Colorado, right? Denver is such a busy airport now. It's
Oh,
such
for
a
sure.
pain,
Hmm.
right? So we really stay out of the Denver airspace, and otherwise we go pretty high. So the small plane
Yeah.
will have to have a pressurized cabin.
Gotcha.
That's
Cool.
sort of the
Well, that's neat.
logistics we were just working on.
Yeah. Yeah.
Yeah.
Have
Hey,
you,
Emily,
mm,
I'm sorry, go ahead.
sorry, Owen. Just one other thing. Have you talked to anyone with like dinklage feeders or like Five Rivers, any of those? Or are
I have
you
not.
kind of working with them
We were
or trying to
supposed
work with them?
tomorrow. Yeah, tomorrow. I'm I'm meeting with, and I'm sorry, I'm forgetting Travis's last name, but the new director, Bill Hamrick's. Tomorrow I meet with Bill Hamrick, whose name is Travis, whose last name is not coming to me right now. I meet with him tomorrow. We were on the schedule to talk to the committee, the Rocky Mountain Ag Subcommittee. And when we did I gave some updates on the 2021 and 2022 experiments to the Mountain Ag Subcommittee, and we were going to talk to them again in February, but then the meeting got canceled. So we'll get back on the agenda to talk to that group whenever there's the next meeting. But if
Yeah.
you have people that you immediately come to mind would be interested in chatting with me, I would love to be
Yeah.
connected.
Yeah, I
I'm just
can
at that beginning stage, right? Like
for sure.
of planning this, and so now is the time to start these conversations.
Yeah. Yeah, I can keep my eyes out and I work with conservation districts all in this corner of Colorado and so I have several connections, to a lot of things so I'll see what I can do and yeah. So,
That would be great. I'd appreciate it. Yeah.
yeah.
Even if our science, I know that, there's proprietary information about different practices and things like that. But even if we could know that there were people in certain locations who would really value this information, then I would direct the plane to make sure that there was good sampling in that area and we could
Yeah.
pass it back to them, right? Because that's
Perfect.
that's
Yeah.
our goal, is to sort of really enable with these observations a variety of different science questions to be answered.
Hmm. Yeah, that's awesome.
Awesome.
And
Thank you.
um, one more thing. Can you go to the slide with the map? And I would find
Which
out or
map?
figure out the map where it said Yuma, where you said where you
Oh, that's
thought it
not
was
Yuma.
Yuma.
Not
It's
Yuma,
not.
right? Is it?
That no, I don't
No.
think it is.
No,
I
it's
was
not
trying to
Yuma.
figure it out.
So in this paper, we had five. This is A to D, this panel. And I was like, oh, I was like, no, I don't have Yuma. Yuma was D. So it's not Yuma because there's 34,
Yeah. Yeah.
right? So,
Yeah.
and there's too many oil and gas wells. So that was
Yes.
just me kind of, yeah, I had put in the D as the example where it
Yeah.
shows three different facilities all together, but then I put this one in.
Yeah.
So
Oh, no, it's fine. I was just trying to figure out where it was because I was curious. So now you can go now. Oh, and sorry.
No, no, that's
sorry.
fine,
Go ahead,
Kristen.
Owen.
Thank you.
Yeah, so maybe you said this already, Emily, and I missed it, but in addition to the aerosol intake sensing that you're doing, do you have any spectral sensing that you're going to do that relates, for example, near IR for heat analysis or whatever?
No. And I think that that is actually that is a great question. So, what would be ideal would be to fly, I think, both in situ measurements, like what we're doing, where we pull into the plane, and remote sensing of surface properties. And that would be the best way, right, to connect from the satellite to the ground.
Right.
And so, no, those are not being supported. The other issue with having, as I understand it, and again, I'm not the PI for the large plane, but I've been the PI on other large aircraft missions. And so the way the large plane is flying to do these calculations, and Jeff, you can jump in if I'm not explaining this very well, needs to fly low to the ground, right? And so that's not ideal for remote sensing. It would be better to have the aircraft situated higher. And so the flight patterns that are needed are not perfect. In other NASA missions, they've often had two aircraft flying at the same time, one with a remote sensing payload up high, and one with an in situ payload lower down. But we don't have funding for that. So
Okay.
it would be a great place to like augment with surface observations or think really strategically about aligning with the satellite overpass.
Thank you.
No
Oh,
problem.
thanks, Emily. And I know you got to go for your next meeting, but there is one comment or question in the chat. Do
Sure,
you,
let me just open it.
okay.
Do you imagine there's a future to compare with the? I would think so. I'm not as familiar with the Sentinel landscape protected areas. It, do you know, Jeff, about these Sentinel landscape protected areas? Yeah, I don't, but I just Googled it. Okay. This is we'll look into this. And actually I can ask someone from the Sentinel team to think about that question with us. So I don't know the answer to that, but thank you for it.
No worries. I get it. Perfect. All right. Well, thank you so much for
Thank you
joining
so
us.
much for the opportunity to yeah, start talking through this and hearing questions from different communities. It's a really it's really generous of you. So thank you so much.
Of
And
course.
don't hesitate to yeah reach out anybody. We're at the front edge of this, so it's a great time for us to think about how to leverage it best for Colorado. I think so.
I will share your contact information and then I'll share with you the contact information from some of us in here as well.
That sounds great. Thank you.
You're welcome. Good luck. Have fun.
Thank you. Bye, everybody.
Bye.